Today we're going to be looking at an operation called prime factorization. This is an operation in math that it sounds kind of complicated, but it's really not that hard, and it has a lot of very useful applications. So before we begin learning how to actually do this, we need to go over two quick vocab words that would be helpful to help us understand what this is. The first word we're going to look at is a factor. A factor is simply a number that can be multiplied to make a given number. So in other words, if I give you a number, let's say the number 6. I'm giving you the number 6, and so the factors of 6 are numbers that can multiply to make 6. So what numbers can be multiplied to make 6? Well, you can multiply 1 times 6 and get 6, when you're right here, or 2 times 3 would make 6. So you would say that 1, 6, 2, and 3 are the factors of 6. The other word that we need to cover is the word prime. I guess we're talking about prime factorization, so it makes sense that we need to know what a factor and what prime means. Prime number is simply a number that has exactly two factors, 1 and itself. So a prime number is any number that only has two factors. One factor is 1, and the other factor is the number itself. So let's look at a couple of examples. 3 is a prime number. What are the factors of 3? What numbers multiply to make 3? Well, the only ones that do are 1 and 3. 1 times 3 makes 3, and those are the only two numbers that multiply to make 3. Another example would be the number 11. What numbers multiply to make 11? What are the factors of 11? Just 1 times 11. Other examples are 2 and 5, 7. These are all prime numbers. So now that we know what a factor is, and now we know what prime means, we can go ahead and learn what it means to put these together and find the prime factors of a number. So the first number that we're going to find the prime factorization of is 24. So what I'm going to do is I'm going to break this down using a factor tree. So what I need to do is find two numbers that are factors of 24. Any two factors of 24 will work. So there's more than one option. I'm going to pick 6 times 4. 6 and 4 are factors of 24. 6 times 4 makes 24. So what I'm going to do is keep finding factors until I have prime numbers, and only prime numbers. So since 6 can be broken down further, I can break it down to 2 times 3. I'll continue. And 4 can be broken down to 2 times 2. Since all these numbers that I have now are prime numbers, I'm done. The prime factorization of 24 is 2 times 3 times 2 times 2. And you can think about it. 2 times 3 makes 6, 6 times 2 makes 12, and 12 times 2 makes 24. Let's do one more example. This time we have some variables. Variables are actually easier to break down into their factors than numbers are. So let's start with 36. I need two factors of 36. Any two factors will work. I'm just going to pick 6 times 6 because that's nice and easy. And 6 breaks down to 2 times 3. And so does this 6. And then I'm going to break down my variables. X squared, we know from our study of exponents that x squared breaks down to x times x. And then y to the third breaks down to y times y times y. And then z is simply just z. So that big long mess there, 2 times 3 times 2 times 3 times x times y times y times y times z, that is the prime factorization of 36 x squared y to the third z. Because when you multiply all of these prime terms together, you end up with our original term.